Good. We are on episode 1, part 5, part 4. Yeah, I think it's part 4. We are now dealing with properties of binary operations. Properties of binary operations. Once under numbers operations, the properties is either commutative, associative, distributive, identity, or inverse, and that of closure. Once binary deals with operation sign, then we have a belief that its properties relate the same as that of raw numbers, raw numbers. So for us to handle this, then under binary operations, these are the few properties we can discuss, which is closure property, commutative property, associative property, distributive property, identity element, and that of inverse. So I'm taking each of the property one after the other. For now, I'm handling closure property. So let's look at example 1. An operation star is defined on the set of raw numbers as on the set T, on the set of raw numbers on the set T. So you are given a particular set, and the set has its possible element as A, B, C, and you've been asked to show that the operation star is closed. Then we need to understand what a closed property is. We need to understand what a closure property is all about. Watch here. I'm giving a scenario. You are given a set A, and its possible members is 1, 2, 3, 4, 5. And you are given two numbers, which is M star N as M plus N plus 1. This is the formula given. And you are asked to show that star is closed. I'm using this illustration to explain how to go by this. First of all, we need to understand closed. When we say something is closed, meaning, let's pick any two numbers from here. Let me pick number like 2 star. Let me pick a number like 4. And I'm to put these 2 and 4 into this formula. Meaning I'm going to get 2 plus 4 plus 1. What is the result of 2 star 4? 2 star 4 is giving me 7. Alright. And you are asked to show that the operation is closed. Watch here. Since 7 is 7 part of set A, is 7 a member of the given set A? No. Why? Because 7, we have the set as 1, 2, 3, 4, and we can't see the 7 here. So since 7 does not belong to set A, since 7 as the answer is not a member of the set A, then the operation I'm dealing with, the operation star is not closed, because the answer is not a member of the given set. In that case, it cannot be what? Closed. In that case, it is not closed. So for it to be closed, we were expecting that the answer, if we had the answer like after solving 2 star 4, and we had the answer to be like what? 3. And from the set A, can't we see 3 here? So once 3 is a member of the given set, Once 3 is a member of the given set, then we can say that the operation star is what? Closed. So meaning close behave like something like two numbers operated, and we are expecting the answer should be a member of the set we are dealing with. The answer we are getting should be a member of the given set we were asked to discuss. So if the answer we are getting is not a member, then it is not close. On the other side of the story, or on the other hand, if the answer we are getting is a member of the given set, then we can say that the operation is close. But with our case, with what we are seeing here, 2 plus 4, 6 plus, is 7 a member of set A? Can we see 7 here? No. No. Then we can say that since 7 does not belong to set A, then the operation is not close. Watch here. One may choose to pick a number like 3 star 5. After putting in 3 and 5 into the formula here, which is what? 3 plus 5 plus 1. What is the result? 3 plus 5, 8 plus 1, 9. Is 9 we are getting here? The 9 we are getting here. Is it a member of set A? Can we see 9 here? So we say that since 9, the answer 9 does not belong to set A. Since 9 does not belong to set A, then star is not closed. So that's the meaning of close. That's the meaning of close property. So let's come here. We are asked to show that the operation we use to draw the table here, the operation star, is closed. So what I'm going to do is I will pick 2 random numbers, one from the vertical lane and the other from the horizontal lane. So I will just pick any 2 numbers of my choice. So I choose to pick A against C. Let me read this from the table. Let me read the answer A star B from the table. So I had my A and C. And the answer is giving me what? A. The answer is giving me A. Can we say that is the answer a member of the set T? Is the answer I'm getting a member of the set T? Meaning it is close, it is within. So once the answer is within the given set I'm working under, then it is close. So what will be my conclusion? Also, let me try another one. Let me try another random picking. Let me pick B and A. So B star A. B star A. When you match, you are getting what? C. Is C also a member of set T? Yes. C is also a member of set T. Finally, let me try another one. A against B. C star B. Let me check. C, this is my C, and this is my B. Let me match it. The answer to, so C star B, the answer is B. Then you ask yourself, is the answer you are getting a member of the set T? Yes. And what will be your conclusion? Then you say that since A, C, and B, or let me use these two to draw my conclusion. Let me use these 2 answers. Let me use these 2 answers to draw my conclusion. Since A, C, as my answer no, belongs to what? Belongs to set T. Then the operation I used to draw my table was what? Star. Then the operation star is closed. That's what you are going to mark. So the evidence is A star C. the answer was A. From the table, so I will say that from the table, random picking any two numbers of your choice. So I choose A and C. So this is my A, this is my C. From the table, I had the answer to be what? A. And at the same time, I wanted to be sure of what I'm doing. So I choose another set of numbers, which is B and A. So B, A. My B is here, my A is here. From the table, I had the answer to be what? C. And finally, looking at the third example, which is C, B. So from the table C and B, I had my answer to what? B. So looking at the three examples here, you could see that I had A star C as A, B star A from the table as C, and C star B from the same table. I had my answer to be what? B. And you could realize that my answers I'm getting, which is A, C, belong to the set T. Then I can say that the operation I'm dealing with is what? Closed. The operation star I used to draw my table, which is star here, is closed. So this is how to go by the closure property. Always your answer you use in performing the operation should be a member of the set you are dealing with. In that case, then you can say that the operation you use in running the work is closed. On the other hand, or on the other side, if your answer you are getting is not a member of the set you were given, it means straight it is not closed. Meaning the operation you are working under is not closed. So always give us the evidence and draw your conclusion. Give us the reason, then you will be awarded the marks. You give us the evidence, you draw conclusion that since answer A, answer C, A belong to set you are dealing with. Yes, it's also, the answers I'm getting is also a member of the set I was given. Then we can say that it is closed. Thank you for watching. But remember, subscribe is very important. Go over and over with the video and it will be of help. It will help you. Get a textbook, give it with a related example. Try if the video can be of help, it can impact you. You just don't watch the video just like that. Get a textbook, open binary operations, get an example related to closed property, and try it and see whether it can help you. With the understanding here, whether you can make an impact in your textbook, whether the video can be an impact to your life as you go by with binary operation. So far as closure property is concerned, try it and it will be of help to you. Thank you for watching. Yeah, now.